Alright, what's up guys? In this video we're going to pick up with some vector calculus here. We're going to talk about some line integrals again. So I asked to use a line integral to find the area of the given ellipse. So given the ellipse x squared over a squared plus y squared over b squared is equal to 1. So to find the area by line integral, we just use the following formula. Okay, so the formula is A, which represents the area, is equal to the line integral x dy, and that's going to be equal to negative line integral y dx. And remember, we can just write that as 1/2 times our line integral negative y dx plus x dy. Okay, so that's the formula for the area using a line integral. In our case, to be a little bit more specific, just to kind of prevent any confusion with the full formula up here, you can just write it this way. A is equal to 1/2 line integral negative y dx plus x dy. I just wrote out the whole formula because I wanted you to see it. But that's what we're going to be working with here. Now, the first thing that we need before we can do anything with this particular problem is we need to parameterize this ellipse. We need the elliptical path, basically. And so remember the parametric equations for the ellipse, or how we parameterize the ellipse. So for the ellipse, remember that it's going to be x is equal to a cosine of t, and y is equal to b sine of t. And remember that the range for t, or t is going to be between 0 and 2 pi. So you will need to memorize the parameterization of certain figures, certain surfaces, certain curves, things like that. Once you get into vector calculus, you should have done a fair amount of parametric equations. You should have done a fair amount of parameterizing surfaces and things like that, parameterizing curves, that sort of stuff. So this may sound daunting, but actually once you get here, you'll pretty much know how to do this already. But that's something that you definitely need to remember how to do if you plan on doing any line integrals or surface integrals or anything like that in the future. Okay, so that's what we have. Okay, so obviously dx is just going to be the derivative of x, and dy is going to be the derivative of y. And again, they're both going to be with respect to t when we take the derivatives. So let's go ahead and set the line integral up here. So here's what we got. We got a is equal to 1/2. The limits of integration are going to be from 0 to 2 pi. And we kind of just got to do a bit of a direct substitution. So we got negative y. Okay, so that's going to be negative b sine of t. That's going to be multiplied by dx, so that's going to end up being negative a sine of t. And then we're going to add that to a cosine of t multiplied by b cosine of t. And remember, this is all going to be integrated with respect to t. So you should be about right there. Okay. Now, in this case, we can go ahead and factor out an AB. We factor out an AB multiplied by 1/2. I can write that as AB over 2. And then I'll have integral from 0 to 2 pi. Now remember that I'm multiplying two negatives here, so that's going to be a positive. So really what we have here is sine squared of t. Over here, again, I factored out the AB because I have an A over here, a B over here, A over here, a B over here. So I just factored out front, multiplied it by 1/2. And again, so this is just going to be cosine squared of t and then dt. Okay, so this is where you should be at with this part. Now hopefully remember that this is just 1. Okay, so effectively what we're looking at is we're looking at AB over 2, the integral from 0 to 2 pi. And since that's just 1, we're just multiplying that 1 by dt. And so we're essentially just integrating from 0 to 2 pi dt multiplying by AB over 2. So remember, this is just essentially going to give us AB over 2 multiplied by 2 pi. The 2's cancel, leaving us with just pi AB, which would be the area of our ellipse. So your final answer here, we're asked to find the area of the ellipse by line integral. Your area here is going to be pi AB. All right, so that's your final answer. So let me circle that for you. So let me know if you got any questions about how I arrived at my final answer, but that is how you find the area of an ellipse by line integral. All right, guys, y'all take care. I'll see y'all next time.